founded in October 2020 for the development of the concept and practical understanding of the topics of the engineering. And primarily, we are focusing on the oil and gas domain. And our current services are we are organizing different webinars, workshops, software trainings, and a set of internship for all the graduates and students. And we are providing the opportunity to learn from the e-platform. You can visit our site www.scholargate.com, and you can follow us on WhatsApp, on LinkedIn, Instagram, Facebook, Twitter, YouTube, and you can join our official group in WhatsApp. And today we are here with the webinar on enhanced oil recovery, and the mentor of the webinar is Dr. Ahmed sir. So he will be sharing the screen.
So now I am the host. I will share the screen with you. I bring my slides. Do you see the slide?
Yeah.
Okay, you see it. I will start now. My lecture as a webinar almost for 60 minutes, 1 hour, and plus maybe 10 minutes more, depending on how it goes. So as the moderator, Mr. Nithi mentioned, I am the speaker for this. The agenda for today, for this seminar, we're covering something on reservoir properties, reservoir drive mechanism, the pressure trend, how do they recover the oil, primary, secondary, and tertiary. We talk about some conclusion, and then I open for you question and answer, or maybe use the chat side for your questioning as well, if you wish. So far, we have a good number of attendees, about 50 attending. And I thank ScholarGate to give me this opportunity to share with you my knowledge and my experience. This is a free webinar, a kind of volunteer, in order to share experience and knowledge with you. And I'm assuming most of you are students, and most of you are petroleum engineering discipline. Not all of you, but most of you. That's what I'm assuming. The aim is very much to talk about the methods of recovering the oil. As you know, the oil exists in oil fields and reservoir inside the rocks, and they can come out to the surface due to some internal energy in the reservoir. We call them mechanism derived, or the derived mechanism. So we have some oil already exists in the field. We call it original oil in place, or sometimes say IIOP, initial oil in place, or initial in place oil. And that will be recovered to the surface due to the energy inside the reservoir, either by water derived, which is the best one, or you can recover between 35 up to 75 if you are lucky, of the oil in place. Or you have a gas cap, or maybe by dissolved gas. They call sometimes the depletion derived mechanism. Most of the reservoirs works in combination. So maybe they have a gas cap and a water derived. Maybe they have a water-derived and a dissolved gas, depending on the structure and the geology of the reservoir. But to understand enhanced oil recovery is very much crucial and important for you to have understanding for your reservoir. A knowledge about the reservoir is important, including permeability, porosity, type of the rocks, heterogeneity, and so on. And the pressure in the reservoir, type of the oil, wettability, contact angle, adhesivity, many other factors need to be understood before you do any enhanced oil recovery. So we have primary, and that's from nature. We have the gas also could be recovered as well by same principle of derived mechanism. Most of the gas field, they have a very high recovery factor up to 90%. But oil fields, they don't have recovery factor, maximum 75%. That's maximum. But most of the time, they could be 40 to 50%. So the oil will be left behind, need to be recovered. I need to get it out. Nature is not enough. That process of recovering oil left behind, they call enhanced recovery or enhanced oil recovery, EOR. So the process designed and operated by the engineers. You have to intervene in the reservoir to get the oil out of it. That process of you put yourself in the field and getting oil out of the reservoir, not depending on natural derived mechanism, depending on your designing, we call it enhanced oil recovery. The enhanced oil recovery will be subdivided into two types, either secondary recovery or tertiary recovery. Either secondary or tertiary. In secondary, most of the time they talk about water injection, water flooding, gas injection, gas flooding, and so on. And these are important to keep in mind. In the tertiary, as a stage number 3, when the secondary recovery finish and cannot recover more oil, but still oil left behind, we need to think about other techniques to get the oil out. So we call tertiary recovery. Example of that nowadays, they use CO2 injection. Chemicals such as polymer and surfactant, heat such as steam and hot water sometimes, all these come under the tertiary recovery. Depending on oil as well, is it heavy or light? Is it high saturation or small saturation? But at the end of the day, you are recovering some percentage, but not the all. You put a big project on water injection or water flooding, you spend good money on it, millions of dollars, but you will never ever recover all the oil. You recover some of it, maybe 30% of the remaining oil, maybe 40%. So I did nature 30%, water injection 30%, that's 60. The remaining 40%, I need to get them out. That's what we use tertiary recovery. So our lecture will cover very much on tertiary recovery and secondary recovery as well. Explain, give you an idea. No calculation here. I'm just giving you an idea because it's only 1 hour session. I will not do any calculation or designing, but I will tell you, I'll answer the question why. So why do we do? We said why and how. Why do we do enhanced oil recovery? Is to recover the oil which is remaining in the field because there's not much energy in the reservoir to push it up. The oil need to be moved. It is immobile. I need to move it out. So that's the reason why. Why immobile? Because I lost the energy in the reservoir. What do you mean? I mean, I lost the pressure of the reservoir. The reservoir has no more pressure inside it to push the oil up. So I am building up the pressure by water injection or gas injection. Or the oil is very sticky, adhesive oil. It stick to the rocks itself. So I need to take it out of the rocks. as if I am washing the rocks. So I use chemical in this case. We call sweeping chemicals or sweeping efficiency. So that is the answer why we use it. And also how we use it, as we said, we use the water or gas, natural gas, or sometimes CO2 gas, miscible, and that's going to be explained to you step by step. As I said, it's 60 minutes only, so I will try to give you as much as I can information I need. And I hope that is clear so far, and I hope also my voice, you hear it well. So you see my slides and you hear my voice, I will
Yeah.
continue. Okay, thank you, Nithi. So what is EOR? And so we have also, if you are a petroleum engineer, you have something called IOR. IOR. IOR is more general word. And the I here stand for increase the oil recovery or improve the oil recovery. So IOR is a general word. Part of it is EOR. How can I increase oil production? Either by water injection, water flooding, gas injection, or maybe by use ESP, electrical submersible pump, or I use road sucker pump, or I use gas lift. So that is an IOR, which is more general, covering both. But EOR itself is very much talk about either secondary recovery or tertiary recovery. Secondary, we call WI, water injection, GI, gas injection. And the idea of it, you see this word, repressurize. I have lost the pressure of my reservoir and I want to pressurize it. So I do gas injection or water injection. Same as in the tire of the car. If the tire of the car has no air in it, you pump air into it. A puncture tires. Or if you be a football, you put the air in the football. You're pressurizing it. That is the how they do it, by injecting gas or water, which we call secondary recovery. And the idea, you are targeting what is left in the reservoir. How much oil left behind, I need to target it. And in this case, I can't get the oil out. So try to differentiate between EOR and IOR. IOR is more general word, more umbrella. Yani under IOR, we have the EOR. So the big umbrella is IOR. So in this little chart in the front of you, we talk about these things, which is we say, if you see the IOR, the orange arrows here, is covering both the EOR secondary and the tertiary. And that's important to keep in. So primary recovery, I am recovering oil from my rocks, from my reservoir, either do natural or sometimes artificial. I put ESP, for example. But if I want to build up the pressure, you see this here, a pressure maintenance. That's a secondary recovery. Or water flooding. Water flooding is washing the rocks. Try also to differentiate between these two words. If you have a piece of paper and pencil beside you, write water injection, and we have water flooding. Water injection is to build up the pressure inside the reservoir. Water flooding is to wash the rocks, to sweep the oil out of the rocks. We call it water flooding. Not much pressure increasing in it, but little pressure increase, but the aim is to wash the rocks. Water, I'm going to show some slides in a minute anyway. Then we have tertiary recovery, and that is could be classified as thermal, chemical, miscible, immiscible, and so on. We're going to mention these as well. So thermal, in certain oil fields, even in India, you have in India as well, some oil fields are heavy oil, and they take the oil out by injecting steam or hot water. And also in India, you have some project on CO2 injection as well, on polymer, surfactant you have. So these are very much techniques come under the title of tertiary recovery to take the oil out of the rocks. So in tertiary recovery, we don't have pressure buildup. We are very much having the idea of washing the rocks, sweeping the oil, make the oil less adhesive to the rocks. That's the idea of the tertiary recovery, actually. So secondary recovery, only two methods in secondary recovery, either water or gas. Gas injection or water injection, sometimes a gas flooding or gas or water flooding, we call secondary recovery. Tertiary, no, is wider, the big list. In tertiary, there are about 22 techniques in EOR. So remember, tertiary has almost 22 techniques for the tertiary recovery. Well, that means take the oil out of the rocks in this case. We're going to mention some of them in a minute. So at the end of the day, if you imagine your oil reservoir as a barrel of oil, and that's the initial oil in place. So from the nature energy, you can recover up to 25%. So if I have a field, whatever field in India, maybe offshore Mumbai Bay, I call it Mumbai Bay, the offshore side of it, or you have something near Chennai area, and the oil is there, let us say 100 million barrel under the ground. So in the primary, you recover 25,000, 25% of it. So the remaining 750 million, I need to recover it. So either I do water flooding, because secondary, or I do the tertiary. And under the tertiary, we have so many subtitles, such as CO2, polymer, surfactant, chemical, thermal, miscible, immiscible, you name it, bacterial. There's so many subtitles for the tertiary. And that's the idea now. The business never stop, it will continue. The business is never stop and it will continue. Again, I repeat, if you have any doubt or any question, just write it on the chat box, then we discuss it at the end of the session. The session is recorded now by your administrator, and maybe he will put it on the YouTube as well. So you see here the list. This table in front of you, or this diagram, all for the tertiary. Every single box here is tertiary, no secondary. So remember, again, I'm going to say a primary recovery, secondary recovery. Primary is on nature. Secondary is water injection or gas injection only. And tertiary, you see the list in front of you? Count them. Every single box is a method. So 1, 2, 3, 4, 5, and so on. You can imagine. So there are hundreds or tens of them, all come under tertiary. Different application. So sometimes I use here, for example, if I take this box, steam, we call thermal, a steam injection. And I do it in different ways. The steam cycle, steam assisted gravity drainage, steam with vapor exploration or experiment, SAG, that means steam and gas application, in-situ combustion, and also under the dry and wet. Under the non-thermal, we have different as well, such as chemical or miscible or immiscible gases, could be CO2, could be flue gas, could be nitrogen, could be what we call the alkaline surfactant polymer, and many other chemicals you can use. India oil fields, they use chemicals quite a lot. They use chemical, very common for them. And also sometimes in heavy oil fields, they use the steam as well, as far as I know. I came to India more than 20 times, and I know little knowledge about India oil fields. So that the idea of tertiary, as we said, miscible and immiscible. See this box, miscible and immiscible. So it's microbial, sorry. The difference between miscible and immiscible, I'm looking for the word immiscible maybe in this box. Here, immiscible gas derived. So we have miscible and we have immiscible. The difference between miscible and immiscible is the idea of having the oil or the gas are mixed together, make them easy to flow, which is immiscible. But the immiscible, they don't mix, either because of their purity or the pressure is not enough, or their nature is not going to be immiscible. The miscible is better. If you somebody asks you, which is better to get more oil, miscible or immiscible, say immiscible is better, because miscible is going to wash all the oil from the rocks. In miscible, we can recover and wash the rocks as if you wash your hand with soap and water. Take all the grease out of the hand. So that's the idea of difference between miscible and immiscible. When it could be miscible, when it could be immiscible, depending on the pressure of injection, or sometimes depending on the polarity of the chemistry of what you inject. So these are good dimensions. If you remember to my first slide, and I said you need to know or be aware about this reservoir properties. So that's important to know your rocks. In reservoir properties, you know what you need? I need to know thickness of the rocks. I need to know the type of the rock, sandstone or limestone. Is it fractured or not fractured? I need to know permeability, porosity, saturation. Is it water? Is it water weight reservoir or oil weight reservoir? Weight, W-E-T. That's important for me. Is it homogeneous, heterogeneous? Is it clean rocks? Is it shell content in it and muddy inside it or not? All these are important to know about your reservoir. So here in reservoir, the basic reservoir, at least you need to know Darcy equation. Darcy equation. If you are a petroleum engineer, I'm sure you know, and you heard about Darcy equation. And these other things you need to know about as well, about reservoir. Waterability, imbibition and drainage that has a connection with the saturation of oil and water. Saturation, how much capillary pressure. Mobility ratio. Mobility ratio is the ratio between the speed of oil and water. And when you do injection, you need to make the oil faster, moving faster than making the oil faster than the, or make the oil faster than water. Don't make the water move faster. If the water moves faster than oil, then you didn't do any job. You just inject water and you produce water. So make sure you have the right type of injection and right ratio between permeability and viscosity of the oil. Usually should be more than one. The reservoir fluid properties, my oil viscosity, density, saturation content, and other factors. The IPR and OPR, inflow performance relationships, and the outflow performance relationships. You have to do some PVT studies as well to understand your reservoir. So these are needed before I decide to build up or to manage or to pay money for enhancer recovery. I should have some knowledge around these points in front of you. Darcy equation is important. This is Darcy equation for what we call radial flow. Sometimes we have linear and radial. This is the basic one for radial flow. What's your aim? Why do you do water injection? Why you do gas injection? Why do you do enhanced oil recovery? In order to increase the production, I need to make Q large. Put the equation in front of you and ask yourself, what shall I do with this equation to make Q naught, which is oil flow rate, is high? STB stand for stock tank barrel per day production. How can I make production very high? I need either make the pressure high, so water injection, PE is high, or maybe I make the viscosity small by injecting some chemical to make it miscible, or maybe by increasing the value of K by maybe acidizing or fracturing. So this is your aim at the end of the day. Your aim is, how can I make Q as high as I can? Put that equation in front of you and ask yourself, what shall I do to make Q more? By increase the PE, I can increase PE by water injection and gas injection, or make mu naught small, viscosity of oil small, by using miscibility or chemicals such as polymer or surfactant to make the oil viscosity small. Or K, which I cannot change very much, but if I make K is larger by inject some acidizations. H I cannot change, the thickness of the rocks. RE and RW I cannot change very much because these are geologics. And B naught I cannot change very much as well, because B naught has a connection with the shrinkage factor and how much gas being dissolved inside the oil. But this is the idea of enhanced recovery based on using Darcy equation. So we have the enhanced recovery in that secondary, tertiary, and in secondary we said water injection, gas injection or flooding, and sometimes the gas cap derived. If I want to take as a history and knowledge, so usually enhanced recovery thermal one, this thermal, this color, the gray colors. So we have on the y-axis is the production rate, barrel per day. On the x-axis, different type of countries using enhanced oil recovery. So in this case, it tells me that enhanced oil recovery are very common in many countries. Somebody said to me, raising hand, I will answer the hand. Why are you raising the hand? You want to ask me or you want to have a comment? Or shall I continue? I continue. So we are in different countries, America, Mexico, Canada, Indonesia, and so on. But as you see, the thermal one is very common. In China, maybe the chemical one, this one is more common, depending from one place to another. In Mexico, again, the thermal is very common. So depending on the type of the oil and the places you are in. Usually the oil, heavy oil, they use thermal. Light oil, sometimes they use chemical, sometimes they use secondary recovery. And the principle of it, you are injecting something inside the reservoir from one point, we call the injection well, and you produce from the other side, we call the producing well. So the injection, what do I inject? Maybe I inject gas. What's gas? Could be nitrogen, could be CO2, could be LPG, propane, and the butane. It could be natural gas, methane. So that's the meaning of gas. The gas is general word here. I inject steam. What do you mean? I steam superheated steam, dry steam. I have steam generator in the surface and I make the steam and inject it inside the reservoir through the injection well. Or I inject fluid. What do you mean by fluid? I'm injecting maybe surfactant or polymer, or even sometimes I inject kerosene or diesel inside the wellbore to recover and wash and make the oil movable. So the oil will move from the injector through the rocks, then we produce it out, as you see. Can I use a pump in the production side? The answer is yes. You can use ESP, you can use road sucker pumps, no problem at all. So you can inject on one side and produce on the other side. This is the basic principle and understanding for enhanced oil recovery. These also some data, statistical data, tell me that if I have light oil, and light oil, we talk about API 35, 36. That's a light oil. 35, 36, 37, 40, we call it light oil. So we can recover a good amount of it by primary and secondary, but with tertiary, I need to use something else to get the remaining oil. Heavy oil, primary is very little, secondary is very little, but thermal is very important, 90%. Tar, there is no primary, no secondary, merely tertiary in tar. Sometimes called rock oil. If you hear about rock oil in America, this is tar. Or in Canada, or in Venezuela, they have the tar. Rocks, no gas, no water derived, just rocks mixed with oil. So they take it out by thermal recovery in this case. If I come back again to this title, secondary recovery, and I want to start a project called water injection. So what should I ask myself? What are the information I need to know before I start about water injection? What knowledge I need? What factors I need? So you think about first about economics. Is it worth it? If there's enough oil in place to build a plant of water injection to get oil out? Water injection projects, it costs millions of dollars, could be 500 million, $600 million to build a project of water injection. So is it worth it? Spend all that money? I need to ask myself. Shall I do vertical flooding? Or shall I do it as a horizontal movement? I need to do some lab work as well. I mentioned to you PVT. PVT is a lab work. You need to understand your oil properties. And again, I need to do a study about mobility ratio, permeability, viscosity, sweep efficiency, vertical or horizontal, the 5-spot technique, the pattern of injection or line derived. 5-spot, if you heard about this word, you choose 5 wells. One of them could be in the center. We call it center well, injection well, and 4 in the corner could be producing well. Mr. Siva Kumar, you want to ask me or later? So later, okay. The producing water, the injection into water zone, we call the water aquifer to build pressures, and also how much pressure is built up. These things need to consider, especially if you are a student and you get a job one day in water injection projects, you need to have some knowledge here and there. And this is a little slide show you the water injection idea. This is water injection, not water flooding, injection. Why injection? Because I'm injecting the water inside the water aquifer, underneath the oil, below the oil water contact, they call WOC or OWC. So my aim is to build the pressure now in the reservoir by injecting water inside the water aquifer. I call it water injection. The aim of this is to build up the pressure of the reservoir. I lost the pressure, I'm building up the pressure of the reservoir. This one, as you see, I come back again. Make a note of that if you have a piece of paper and pencil. We have water injection. This is the shape of it. We have another title called water flooding. And water flooding, you see this blue area. I am injecting the water inside the oil zone, inside the pay zone. So I'm washing the rocks, not building the pressure. No, just make the oil mobile, moving oil. I have oil, but not moving, so I'm moving it by flooding the rocks with water. I prefer to be a fresh water, but if it is expensive, they use sometimes seawater. Or they produce water from the reservoir. After treatment, also they can use it. So this is something you need to be aware about. I repeat again, this title, water injection, and this title, water flooding. They are not the same. Injection, you are targeting the bottom of the oil WOC underneath the oil, but in a flooding, you are targeting the pay zone. You are washing the rocks. Here, you are building pressure in the injection. But in water flooding, no, you are increasing sweeping efficiency. That's the difference between them if there's somebody asks you to comment between them. Water injection usually come after primary recovery. So I produce for a certain number of years from a reservoir, as you see in this slide. On the x-axis, we have the years of producing. And then I say, oh, my oil production on the y-axis is getting small. So I need to build up, I need to increase my production. I do water injection, as you see in this slide. So this is about water injection, secondary recovery. So you see here and here, see the number 50. Maybe after 50 years, after 50 weeks, after whatever number, the oil production gets smaller. I need to increase it. I do water injection. See the curve, the red line, the red curve jumping. Because the pressure is built up, so we have better production. And that's the beginning of the water flooding or water injection, you can name it as well, for a certain number of years. And then also at the end of the time, they will be also depleted and I cannot produce more. So I think about next step after that will be the tertiary recovery. So that's the idea of it. My slide or my title, why and how. So why we do water injection or EOR in order to build up the pressure of the reservoir, which has been depleted, and also to sweep more oil from the reservoir. I'm aware about the time. The time is passing very fast. So in this case, you have to keep an eye on your projects in terms of the good optimization. And in this case, you have to think about factors such as the investment. Money is very important in water and secondary recovery projects. Very important to monitor how much money you're spending. Because if you spend money and you don't recover oil, there will be a waste of money. You lose money. And the money here is not small money. We talk about millions of dollars, 100 millions of dollars. So you are not willing to lose money. Therefore, one of the recommendations for a water injection engineers is to make the expenditure optimize. And that on water flooding, water quality, water quantity, water treatment, the pump maintenance, the pump costing, the production rate, and many other factors need to look into. So the secondary recovery is a part of EOR. We said either water or gas sometime, gas flooding or gas injection. So in water flooding or water injection, I mentioned to you here, we inject the water inside the water aquifer at the bottom of the oil zone underneath the WOC. WOC, water oil contact. In gas injection, you are targeting this yellow area. What do we name it? We name it the gas cap. So if I inject the gas inside the gas cap, I would name this gas injection. Usually the gas is used most of the time will be the natural gas, methane and ethane. Natural gas is recommended. Don't inject CO2 in this yellow area. Don't inject nitrogen in this yellow area because you will contaminate it. You will lose the heating value of it. Not good. But inject natural gas, maybe LPG, yes, maybe. But don't inject nitrogen or CO2. Not allowed. And that we call gas injection, and the idea is to build up the pressure as well. So from one side, we have injection well, as you see in the middle. And on the wing side, left and right, we have the oil producing well. Because the pressure is built up, the oil has more pressure inside it, start to move now from the subsurface to the surface. This is the basic principle of gas injection. So in gas, think about the gas cap you have to have. You cannot use gas injection in what we call it undersaturated oil. There is no gas cap, there is no gas injection. There will be a gas flooding, not injection. So if there is no gas cap, if somebody asks you, we have no gas cap, can we use gas injection? The answer, no. We use the gas flooding in this case, which is similar to this slide. The gas here is targeting the oil zone. I will call it gas flooding. Again, I have to have a good gas supply in the surface. Maybe sometime I need to treat the gas. Gas treated very well as well. At least dehydration of the gas, and it's better to be free from H2S because H2S will cause corrosion if it's natural gas. But CO2 or nitrogen doesn't matter. So you inject the gas inside the oil zone. Some of the gas will dissolve inside the oil, make it miscible. Make it miscible, make it easy to move. So we produce from the other side. This slide, we name it gas flooding. This slide, I name it gas injection. Different. So remember, gas injection, you have to have a gas cap. We call it in petroleum engineering the saturated reservoir. That means oil has a gas and also has a free gas. Here we have no gas cap, we have only oil, we call undersaturated. So inject the gas inside the oil zone. Some of the gas will be miscible. If the gas is miscible in the oil, that means the oil will reduce viscosity. A small viscosity, what does it mean? Mean will be mobile, moving easily, swept easily. Can I, if somebody asks you, can we do 2-in-1? Can we do gas injection and water injection in the same field? The answer is yes. We can do as you see in the slide. We have two processes or two operations in one field. We have gas injection, the one in the center, the red arrow, and we have the blue is the water injection, blue arrows. And the green arrows is for the producing well. It's a combination of gas injection and water injection as well. Can I do in flooding here, this word flooding, can I do also gas and water together? The answer is yes. And we name it WAG, W-A-G, G for gold. And that's water alternate gas. So we will talk about WAG in a minute. But generally, we have this combination. If you have a gas cap, the red one, and you have water aquifer, the blue one, you can do 2-in-1. You can do gas injection and water injection if you wish. I'm looking if I have a slide on WAG. This is WAG. This is WAG. WAG. Water alternate gas. In this case, you see, we have gas injection and water injection. And that if you have a gas cap and water derived. But can I do gas and water in the same pay zone, in the same oil rocks? The answer is I can. What do I name it? I name it WAG. Water alternate gas. What do you mean? I mean, first I inject the gas such as CO2. I keep injecting gas inside the rocks for maybe 4 months, 5 months, 6 months. Then I stop and I follow that injecting the water. So gas followed by water, called WAG. That's a possible as well. Not only possible, I am a professor in petroleum. I recommend that as a consultant. If they ask me, I say I prefer WAG. WAG gives you the basic production rate and it minimizes the costing and give you very better sweep efficiency. So you can get a higher recovery factor by the WAG rather than depending on one only. So that's something you need to look into and consider. If I go back again to my slides and I mention the word miscible and immiscible, this is the meaning of it. The one in this slide here is miscibility, miscible. The gas you inject, the polymer you inject, the chemical you inject, such as surfactant, are miscible, mixed with oil, make it very light, easy to move. I'm aware of time is passing very fast, and immiscible, where they are not mixing together due to purity or pressure or due to polarity or chemistry of them. But which one can give me better sweeping efficiency? The answer is the miscibility give me better sweeping efficiency. Okay? What are the chemicals could be miscible when I inject? It could be propane is a good example of miscible, propane gas. Or it could be polymer, surfactant, or it could be the CO2. But of course, every activity you do has advantage and disadvantages as cost or corrosion or efficiency or availability and whatever. So these are important to keep in mind. CO2 nowadays, people talk about CO2 as a good techniques for enhanced recovery, tertiary recovery. CO2 is come under the tertiary recovery. And CO2 comes under miscible or sometimes immiscible, both. If CO2 mixed with oil and dissolved inside oil, we call it miscible because it has enough pressure to be mixed. If CO2 does not dissolve in the oil, we call it immiscible. CO2, people also talk about environment. If you talk about environment and the global warming, if you heard about it, we will also talk about, oh, CO2 is very good in order to fight the what we call it the global warming, the environmental impact, carbon impacts. I have written a book on CO2 AOR. It's a very big subject. But here I give you just a flavor. So CO2 has certain properties called supercritical properties, suitable to be injected inside the reservoir. So you cannot inject CO2 as a dry or a gas. You have to rise it up to the supercritical with a pressure about 75 bar, then inject inside the reservoir to make it miscible. I will pass faster because this is one of the methods which is good to read about or could be knowledgeable to read about. Many oil companies now consider CO2 as a way of tertiary recovery. So if you are a student, I encourage you to read more about CO2 EOR, CO2 enhancement recovery. There's so many papers being published, SP papers and books written. Try to educate yourself on that because it's coming. The number of projects are increasing. They talk about the speed of CO2 inside the rocks and so on. I will pass for you. And this is the idea of CO2 injection. So you target the pay zone, the oil zone. You have an injecting well, the red arrows, and you have the producing well in the middle. And that CO2 will push the oil, make it miscible, easy to flow, and produce from the other side. We call this the liner pattern. So we have two injector, one producer. You have to have enough CO2 supplied to you by supplying company. And also you have to have pure CO2 purity about 99%. Again, you have to have enough pressure to pump it in. So that's example of, this is again another example of the WAG I mentioned to you already. And it's also WAG CO2, same principle as well, because some of the CO2 will be immiscible, some will be miscible. So the miscible one is better to make the oil moving easier in this case. What about if I have a heavy oil, such as a bitumen or tar? The oil with viscosity maybe 5,000 centipoise or 500 centipoise. 500 centipoise or more, we call heavy oil. So what shall I do? CO2 does not work. Water injection does not work. Gas injection does not work. The answer, do some thermal recovery. Inject steam inside that reservoir. So we have something with steam cycle, half and buff, which is 3 stages like this slide here. So you have a steam in the surface, a steam generator, and make the pressure of the steam around 70 bar and push it inside the rock, inside the well. You keep injecting steam maybe for 5 days or 7 days. They close the well, and go home. You leave the well closed, no production, for maybe 5 days again. We call this soaking time. You see this word, soak, S-O-A-K. Here we have soaking time, soak. So I inject. The injection here they call huff. And the non-producing time we call this soak. Leave the steam working here, melting the oil, make the oil a bit less viscosity, very hot. And then after 5 days, come and open the well. Just open the choke or switch on the pump, and you get the puff, the producing period. So inject oil for 5 days, close the well for 3 days for soaking time, and open the well for production for another 5 days. That's what they call the name cyclic, the cycle. It's only one well in the same well. You are doing the job in same well. Here in CO2 flooding, we have mentioned you have 2 wells. You have injector and producer. In steam injection, no. Same well, one well. Especially in steam cyclic. Steam cyclic. Remember that. Steam cyclics in the one well. Same well will be a producer and the same well will be injector. I hope that's clear. This is the physics and the heat transfer theory behind the huff and puff. How does the heat move from the steam inside the rocks and inside the oil? So if you remember, you have little background on conduction and convection and radiation. You have to go back again to your heat transfer knowledge and study the process of heat moved from the steam into the oil and how much heat is being taken and the impact of heat on the viscosity of the oil in this case. So that's needed from you some heat transfer and the thermal properties of the rocks. Other type of steam called steam derived. No, steam derived same as similar to the CO2 injection, similar. You have to have two wells, one well as injecting well, and you have producing well from the other side. But these wells should not be very far away from each other, no more than 200 meters. Otherwise, you lose the heat. So it should be spacing is no big. Inject the steam and keep injecting steam. You have a steam generator and a steam injector, and the steam will push the oil to the other side. So here we have both viscosity being reduced and the pressure also build up. The steam flooding, same idea, because here not injection, it's flooding. Same this principle. And this slide, I telling you that you have to have a good water quality to make a good steam. My time is running away. I will finish in maybe maximum 5 minutes. Then we have the what they call the SAG, which is the steam assisted gravity. In this case, you have two well. One of their well will be horizontal well, and you inject steam inside it. Maybe the length of that horizontal could be 1 kilometer. And there's another well underneath it, the producing well. Spacing between them about 5 meters, could be sometimes 7 meters, depending on. And that steam will melt the oil will drop through this and come and producing. This tubing, it should be slotted with holes in it. So the oil will go inside and you produce from the other side by having some pump producing. This is also the theory behind the heat movement, heat transfer. This is again, same idea, sagged. And this is sagged, but two horizontal well. This is also sagged, but one vertical well and the other one horizontal. So it doesn't matter. But which one is better? This is better in terms of productivity. We have something also on heat. You are using that also in India as well. I think I heard that in Mumbai base or near Mumbai anyway. They have the in-situ combustion, and the idea of in-situ combustion like this. I make the injector well as a fire well. Remember this fire triangle? You have to have air, ignition, and a fuel, which is the oil. So I'm burning the oil inside the rocks, and that hot burning oil make the oil is very less viscosity. The air injection is a continuous injection by the stove, build up the pressure and push the oil from the injector to the producer. That's the basic idea. You have also to understand the rocks thermal properties and the damage happening to the rocks in this case. But this is also used in India anyway. India, in Oman, in Venezuela, in Canada, and some of the Texas area, they use the in-situ combustion. So the thermal recovery is well known. Other chemicals will be used such as surfactant, washing liquid, same as the washing liquid. Or the washing liquid used for dish, or you wash your hand with oil, with soap. This is soap. Surfactant is a soap. So it's a liquid soap. You mix with water, pound weight, almost half a kilogram. For every bottle of water, you mix them and you pump it inside the rocks to be flooded because surfactant. And we have also polymer, same idea. We prefer to be a water-based polymer. You inject the polymer inside the rocks to wash up. Here, no pressure build up. Here is merely to decrease adhesivity and build up the sweeping efficiency. Sometimes you can inject propane as well, or butane, or LPG. I don't recommend that unless you have plenty of money, because it's expensive, and also could be dangerous in terms of safety, but they use it in certain countries. Microbial culture in the lab, I take the microbes will create for me a biosurfactant. And that biosurfactant could be used for injection or the acid. Sometimes if you leave the food in the kitchen for a long time out of the freezer, the food will be rotten and it tastes very sour food. That's an acid because of the bacteria. Mainly it's H2S. And these are something you need to be aware about. This is the idea of the microbial. I think also they use in China and India as well on limited areas. So I pass faster. Again, microbial. So they have limitation. Every single process has limitation, costing, permeability, pressure, temperature, whatever. Nitrogen could be also used for enhanced oil recovery as gas injection, mainly for gas injection. Again, available and cheap, but not as good as natural gas. But suitable, they use it. If you ask me, do you use nitrogen? Yes, they use nitrogen in certain countries. Yes. They don't use air because air is very corrosive and also can cause fire. But pure nitrogen, they use it. So there's advantage for EOR, building the pressure and increase the recovery factor. I'm just now trying to finish because the time is over. And these are the projects. If I want to build EOR projects, then consider these three elements. The time. It does not build in one day or in 1 week. Take years sometimes, 1 year up to 5. You see, sometimes to make the commercial one take 5 years to 10 years. So you build it step by steps. And that is, you need to be patient. You buy equipment, tanks, pipes, valves, pumps. You pay money. You choose the right location. You have to have a good team working on it. So it's cost, timing, and effort. Then it costs you money, capital costs and maintenance costs, we call expenditure costs, operating cost. And it needs technology. I have to have a good lab work, a good knowledge, a good equipment as a technology. I do reservoir simulation, so I have to have a software. So that is the idea of EOR projects is not as easy. In terms of economy, as you see from this slide, we can say that heavy oil for the steam will be cheap, but it's heavy oil anyway. But if you are using here with the nitrogen or flue gas, they are very much suitable for certain API factors. And this is the economy. This is property, but this is economy. And this slide is talk about the impact of API on the choice of the tertiary or secondary recovery. So if you have heavy oil, small API, the answer is steam or thermal. You have a light oil with a large API, the answer could be nitrogen, could be gas injection, could be CO2 injection. Economy, if you see in this slide, water flooding is the cheapest one. Microbial could be okay, but not very effective. But for sure, surfactant is expensive because you pay money for the chemicals. Polymers, yeah, reasonable. CO2 now is very much used quite often. So the CO2 in the heart of the slides would tell us very economy in this case. This is my last slide, and my time as well is passing already.